Hello there and welcome to a new video on module 1. This video will focus on multiplexers and demultiplexers. So a multiplexer is basically something that transmits a large number of information information units over a small number of channels or lines. What the task of a multiplexer is to basically take multiple inputs, okay, and based on these selection lines is going to decide an output. Okay, so 2n inputs, that means it can be anything, okay, it can be any number of inputs that are corresponding to 2 power n, where n is the number of selection lines. Okay, so if we have 2 power n input lines, then the selector will decide on what the output is going to be. Okay, it is also a combinational circuit. Okay, it has more than one input line, only one output line, and more than one selection lines. There are 4 types of multiplexers that we are going to study, which will be in our course: 2:1, 4:1, 8:1, and 16:1. You see, each of them are powers of 2. Okay, and the first 2:1 multiplexer, we have 2 inputs and only one output. Okay, we will have one selection line because 2 power 1 is the inputs for this multiplexer. So when a is going to be 0, okay, we will have the first input line that will be taken to the output. So input at I0 is going to be the output, but when a is 1, we'll have the second one. We'll see further. So here, whenever a is 0, okay, when the value of a is 0, the mux is going to send the first input to the output. Fine. As you can see here, when a is 0, the data input I0 will be connected to Z, hence Z will be I0. When a becomes 1, the I1 is going to be transferred to Z. In a 4:1 multiplexer, it consists of 4 data inputs, 2 control bits, because now the inputs are 2 power 2, so n is 2, so select will be 2, and only one output, same again. I0, I1, I2, and I3 can be the 4 input bits. A0 and A1 are the control lines, and Z is the output. Here is the truth table. Whenever the selection lines are 0, 0, the first line is submitted. Okay, first line goes to the output. Whenever it's 0, 1, that refers to the second possible combination. Our second input line will be going. When 1, 0, the third one, and 1, 1 will be the fourth line. You can also look at this in binary form. 0, 0, 0, 1, 1, 0, 1, 1 are the binary numbers for 0, 1, 2, and 3. So whichever binary corresponds to the number of the input, the position of the input, that input is going to be sent to the output. We have a question over here which says the data output is equal to I0 only if S1 is 0 and S0 is 0. Okay, so if both are 0, the output is I1. Okay, and hence the equation is I0 S1 dash S0 dash. This means that I0 is 1, S1 and S0 are 0. Fine. The data output is equal to I1 only if S1 is 0 and S0 is 1. Fine. So this is basically, as you can see, the logic or combinational circuit for a multiplexer. Okay, we are given the equations here on how the equations are formed, and then based on these equations we can create the inputs, the gates, and then the output. Fine. This is an ORing because whenever we have multiple different combinations and either one has to be true, we use the OR gate. Okay, and our output will be Y, which is the function for the multiplexer, single output, and we have 2 power n inputs and we have n selection lines. Okay, so when there are 4 inputs, there's 2 selection lines. Our inputs go to AND gate each. Okay, and the selection lines are changed, either it's 0 or 1 based on our equation. So I goes at 0, hence both are going from NOT gate. S0 and S1 both are through NOT gates. I1 is from 0, 1, so the first one goes from NOT gate, but the second one goes as A1. You can see it does not go through the gate, it goes as a 1. Okay, same for I2 and I3. This is the final expression, the total expression for I0, I1, I2, and I3, what each value of S0 and S1 should be in order to transfer the data. Now a demultiplexer, similar to encoders and decoders, a demultiplexer is the opposite of a multiplexer. Hence, since it says here, it's a reverse operation of a multiplexer. Okay, so it receives one input and it gives 2 power n outputs. Okay, a demultiplexer means one to many. Okay, it is the process of taking information from one input and transmitting the same over one of several outputs. Again, data is 1, but 2 power n outputs gives you n selection lines. Classification is the same, just reversed. So 1 is to 2, 1 is to 4, 1 is to 8, and 1 is to 16. If we have a 1 is to 2 demultiplexer, what we have is the input 0 1 0 1, C 0 1 0 1, output is 1 and 2. Okay, so according a 1 is to 2 demultiplexer consists of one input line, two output lines, and one select line. Okay, so one of this is select and the other is the output. Fine. There are only two possible ways to connect the input to output lines, thus only one signal is enough to do demultiplexing operation. Whenever the input in is 0 or 1 or 0 or 1, we have the following outputs. Okay, and since we have one select line, we can consider this as a binary operation. The output will be literally the same of the input of, basically the input and the select can be taken as a binary 0 0 1 0 0 1 1 1. Accordingly, we have outputs. A 1 is to 4 demultiplexer. Similar, it has one input and 4 outputs, 2 selection lines because n selection lines for 2n, and this will be the truth table. The outputs we can take as O0 to O3. Okay, S0 and S1 are the selection lines over here, 0 0 0 1 1 0 and 1 1, and we can draw the similar the pattern for data as the encoder and decoder. Why is this? So because since we have only one input, okay, that input can be transferred to any one line. Okay, we won't have output in all of them, we'll have an output in any selected line. So these selects are gonna tell us when the output is going to which line. When it's both 0, it's obviously going to go to the first one, as we discussed earlier. If it's 0 1, it goes to the second, 1 0 goes to the third, and 1 1 goes to the fourth. And accordingly we can write the data inputs, whatever data it is, and rest will be 0.